Hello and welcome to the Atmospheric Moisture and Severe Weather Lab. The lab objectives are 1. Be able to define relative humidity and how it changes with temperature. 2. Understand orographic lifting and how it influences Pacific Northwest precipitation patterns. 3. Analyze weather maps to understand air masses and weather systems. 4. Understand processes that contribute to day-to-day variations in weather. And 5. Consider the relevance of extreme weather on social or societal and environmental facets. You'll need computer, pencils, red and blue colored pencils. And let's go through the parts. Part 1, the 3 phases of water and relative humidity. So basic water phase change questions, followed by relative humidity questions. And remember from lecture, relative humidity is the actual water vapor in the air divided by the maximum water vapor it can hold, then times it by 100 to get the percent. And so it walks you through how to calculate relative humidity for different temperatures. And then you get to graph relative humidity and temperature over time. You can do this in Excel if you'd like. If you don't like Excel, just do it on this graph. It asks you some questions about the graph. And then we go to part 2 with orographic lifting. So this is when air is forced over a mountain and then goes down the other side. There's a conceptual picture here. So the air mass goes up and over and then down. And of course, as it goes up in elevation, temperature decreases, which changes the relative humidity. You might have noticed, part 2 is extra credit. So all the questions with a Roman numeral are extra credit. There's a special extra credit quiz to submit your answers on. And it's called Orographic Lifting Extra Credit. And again, you just go through and calculate relative humidity and what's going on because of the change in relative humidity with a change in elevation. Part 3, this is required. This is global air masses and fronts. And so here's a picture of what was going on May 3rd, 2010. There was a windstorm, a severe windstorm with high wind gusts, and it created a dust storm. You can see the dust here. Now for that situation, you get to look at pressure gradients and kind of make a weather map here on this map base. So these are pressures in in bars, and then you get to create isobars. These are like contours of pressure. And there are a couple videos that I chose to teach you how to draw isobars. But if you think those videos are lame, you can totally search how to draw isobars and watch other videos to help you learn how to draw isobars. Unless you already know, then don't watch those videos and just go for it. You draw the isobars and you mark high and low pressure, right? Low with an L, high with an H. And you get to shade strong pressure gradients where the isobars are close together, so the pressure is steep. And then draw a few raindrops in blue in areas that you expect precipitation to occur. Now this would be where you think. I bet you're thinking that it would be between the high and low pressure areas where you've got cooler air and warmer air, and where those air masses collide, that's where you're going to be getting some precipitation. And Once you've created a beautiful weather map, you get to submit it, scan and submit it in the discussion board. And more questions and severe weather impacts. This is looking at tornadoes and effects of tornadoes. This is Greensboro, Kansas, May 4th, 2007. An EF5 tornado. Huge. And so go through and ask some questions about that. And except for the weather map, all the other questions are submitted online in the quiz for this lab. And if you have any questions, email me. I believe it's pretty straightforward, but I'm not you. So if you have questions, feel free, ask them, and I will answer them. Good luck, and hopefully it's kind of fun as you do the lab. Bye.